Have you ever looked up at the night sky and wondered how the stars, those glittering jewels scattered across the cosmos, are actually born? Most of us imagine stars forming in calm, serene clouds of gas and dust, like the famous Orion Nebula. But what if I told you that some of the universe's most incredible stars are forged in the harshest, most extreme environments imaginable? Stay with us, because today we're diving into one of the most fascinating frontiers of modern astronomy, exploring how stars are born in the wildest corners of the cosmos, where conditions are anything but ordinary. Let's start by asking, what exactly do we mean by extreme cosmic environments? Imagine places where gravity is crushing, radiation is intense, temperatures swing to unimaginable lows, and matter itself is pushed to its limits. These are environments found near the centers of galaxies, in the aftermath of galactic collisions, or in the distant, primordial reaches of the early universe. Here, the recipe for star formation is dramatically different from what we see in our own cosmic neighborhood. To truly appreciate the marvel of star birth in these environments, consider the obstacles. In some regions, the pressure is so intense that clouds of gas and dust are squeezed together with enormous force. In others, the icy cold of deep space chills these clouds to temperatures just a few degrees above absolute zero. Near supermassive black holes, intense radiation and powerful gravitational forces threaten to tear apart the very material needed to form stars. Yet, against these cosmic odds, new stars still manage to ignite. But why should we care about stars forming in such hostile places? The answer is simple. Understanding this process unlocks secrets about the universe's past, present, and future. By watching stars emerge from chaos, astronomers learn how galaxies evolve, why some galaxies are teeming with new stars while others lay dormant, and even how the first stars in the universe sprang to life. Let's dig a little deeper into the environments themselves. Picture the very center of a galaxy, a place bustling with old stars, swirling clouds of gas, and, often, a monster lurking at the core, a supermassive black hole. Here, the density of matter is extreme, and radiation pours out in staggering amounts. You might expect that such chaos would make star formation impossible. Surprisingly, it's often the opposite. Shocks from colliding gas clouds and the immense pressure can trigger starbursts, episodes where stars form at rates hundreds of times faster than what we see in quieter regions. These bursts give rise to massive clusters of stars, some of which are much larger and more energetic than those born in peaceful nebulae. Now imagine two galaxies on a collision course. As they merge, their gas and dust clouds crash together, compressing and heating the material. These cosmic pileups act as star factories, lighting up the universe with new stars. In fact, some of the brightest and most dramatic star-forming regions we've ever observed are found in these galactic smash-ups. Such environments aren't just extreme, they're transformative, reshaping entire galaxies and breathing new life into the universe. But not all extreme environments are so violent. In the early universe, just a few 100 million years after the Big Bang, conditions were wildly different from anything we see today. The first galaxies were small, their gas almost pristine, containing very few elements heavier than helium. In these ancient times, the lack of metals, astronomical jargon for all elements heavier than helium, made it possible for the first stars, known as population 3 stars, to grow to enormous sizes, many times the mass of our Sun. These giants lived fast and died young, but their violent deaths seeded the universe with the heavier elements needed for future generations of stars, and, ultimately, for planets and life itself. There's another fascinating twist to this story. Sometimes the very forces that help stars to form can also prevent them from forming at all. In some regions, intense radiation from massive young stars or powerful winds from nearby supernova can blow away the gas and dust, halting star formation in its tracks. In others, gravitational tides from supermassive black holes can shred clouds before they ever have a chance to collapse. These cosmic tug-of-wars create a delicate balance, influencing when and where stars can form. So, how do astronomers study these distant, tumultuous stellar nurseries? With the help of powerful telescopes, like the Hubble Space Telescope, ALMA, and the James Webb Space Telescope, they can peer through the dust and gas, capturing light from the earliest and most energetic star-forming regions. By analyzing this light, scientists piece together the physical conditions, ages, and chemical composition of newborn stars, even in the farthest reaches of the universe. Research into extreme star formation isn't just about exotic cosmic fireworks. It has profound implications for our understanding of the universe. For example, by studying starbursts in colliding galaxies, astronomers can explain why some galaxies evolve rapidly while others remain relatively unchanged over billions of years. Investigating the birth of stars near black holes helps us understand how these cosmic giants influence their surroundings, shaping galaxy evolution on grand scales. And by unraveling the mysteries of the first stars, we gain insight into how the universe went from a dark, featureless expanse to the vibrant, star-filled cosmos we see today. But perhaps the most inspiring aspect of this research is what it tells us about resilience and creativity in nature. Even in the harshest, most forbidding corners of the universe, the seeds of creation take root. Stars are born, galaxies evolve, and the cosmic story continues. If you're fascinated by the idea of stars being born amidst chaos, of galaxies colliding and black holes shaping the fate of entire star systems, then you're in the right place. Stick with us as we journey deeper into these cosmic extremes. There's so much more to uncover. How do these environments affect the types of stars that form? What happens to planets in these turbulent nurseries? And what can we learn about our own origins from these distant cosmic dramas? Don't go anywhere. The universe is full of surprises, and the story of star formation in extreme environments is just beginning to unfold. Join us as we continue to explore the wild, beautiful, and utterly fascinating ways that stars are born, even in the most unlikely places. Stay curious, and let's keep reaching for the stars together.